Hi, welcome you all for my session Embedded System Design. Our fourth topic is processor selection for an embedded system. So, processor selection is not an easy task for an embedded system. It is not possible to simply select a processor from your favorite list. Several factors ought to be considered when selecting a processor for an embedded system because embedded systems are designed to operate in different climatic conditions and critical environments, etc. So, major factors that we embedded depend to select a processor is type of applications, necessary performance, power constraints, special processing, and modern technology. There are different types of embedded processors available in the market. The selection of embedded processors should enhance the user experience by reducing the chance of poor speed, system overheating, insufficient memory, etc. The embedded system in the customer's hand should not make them curse the designer. Instead, the system should make them proud of the technology. Hence, utmost care should be taken in the selection of embedded processor. So, these are the main factors to select a processor in an embedded system. First, speed and performance. Next, optical power usage. And third, peripheral supports. Fourth, advancing processing. And fifth one is cost. Let us discuss one by one. Speed and performance. The most important factor to consider when choosing a processor for an embedded system is its performance. A processor's speed is primarily determined by its architecture and silicon design. The processor performance is evaluated by the number of instructions executed per second and the number of operations per clock cycle. And the advancement of fabrication techniques enabled the packing of more transistors in the same area reduces the propagation delay. So the other techniques, pipelining and superscalar architectures, boost processor performance. Even further, other techniques for increasing execution rate include branch prediction, speculative execution, and so on. Next one is optimal power usage. So increasing the logic density and clock speed have an adverse impact on the power requirement of the processor. So more logic leads to high power density, thereby making the heat dissipation difficult. With more emphasis on greener technologies, and since many systems are becoming battery operated, it is important to design the system for optimal power usage. So techniques like frequency scaling and voltage scaling can help in achieving lower power usage. Silicon on chip comes with advanced power gating techniques that can shut down clocks and power to unused modules. And next one is peripheral support. Apart from processor, the embedded system has many other peripherals to perform input and output operations. It is most important to have the right peripherals to assist the processor in optimized performance. In recent days, almost all the processors used are system on chips. So it is better if the necessary peripherals are available in the chip itself and are called on-chip peripherals. It offers various benefits such as optimal power consumption and effective data communication compared to external peripherals. The peripheral set located outside the system on chip but on the same PCB is called off-chip peripherals or external peripherals. And next one is, and it is also in we have like example of peripheral devices are like timers, A to D and D to A converters, PWM controllers, and serial communication controllers are some of the external peripherals used for processors. Next one is advanced processing. Along with the core processor, the presence of various processors, co-processors, and specialized processing units can add more value to the processing performance. The instructions fetched by the core processor are executed by the co-processor in parallel, thereby reducing the processing load. Some of the popular co-processors include floating point co-processor, graphics processing unit, which is represented by GPU, and DSP, digital signal processing, etc. Floating point coprocessor can be very helpful in applications involving complex mathematical operations including multimedia, imaging codes, etc. So GPU is responsible for re-entering the images on a digital display. It is a parallel processing technology which processes image as faster than the normal unit. It is sometimes called a visual processing unit. And next one is cost. The last factor which an embedded depends to select processor is cost. For all the required functionalities to be built up in a system, certainly the price will be the determining factor during the selection of processor for an embedded system. Consider you are planning to buy a laptop. Among the different specifications, definitely you will look into the processing speed of the laptop. If you need better performance, then you should be ready to invest more money for the system. Additional peripheral sits along with the core processors will make the cost to rise. Hence, system on chip devices are very effective means to cost effectively implemented design. So these are all the major factors needed to select a processor for an embedded system. Thank you.